Hello guys, today we're going to take a quick look at the data centers we have today in our day and age. Let's get started already. Data center infrastructures, how data centers are shaped and how they work in a simple manner. Application user interface, this could be your computer, this could be an ATM, this could be a Facebook interface, this could be an online interface, wherever you would like to put the information that's gonna get processed later on. The server. Server is the device that actually processes the information, your ATM pin, like it says here, your Facebook password or such and whatnot. This is where all of that information gets processed. Storage array, this is where the information that gets processed is taken from. The storage array the server says, hey, I need this information from the storage array. Storage array sends the information so the server can confirm if the pin is correct or not as such so you can log in. Local area network, LAN. LAN is the communication bridge between user interface and the server. It's typically used for short distance communication, such as within a building or a local area. This is where the client sends the information to. From there, the information is sent to the server where it can be processed in a simple manner. Storage area networks, and this is the bridge between the server and the storage array, and it has to be an extremely fast communication because no one wants to wait the ATM line for 5 minutes or 10 minutes. So your information needs to be processed and be sent back and forth real fast. This is what it's used for. How it works, as a simple example, uh, let's say you're shopping, you're buying something. The client sends the information to the local area network that sends it to the server. It says, hey, this person wants to buy something. So the storage area says, we have this amount and what amount of this left. So the server says, okay, you can buy this or you cannot buy this. And in between the SAN and the LAN, provide the connection or the information pass to the server and storage array and the server to the client. This way, you can buy something you want, or you get your money through the ATM because you don't want to wait 5 minutes. It has to be fast. This is how we could use it as an example. You can read right here. Data center topologies. This is a bit of an advanced topic, but I think you'll be fine. The problem in large servers, in large data centers with thousands of servers, network switches get overwhelmed. They can't keep a record of every single server unique hardware address, MAC address. This is a scaling problem. What it means is that network switches, they need to keep the memory of, let's say, 1,000 or 10,000 server IPs, and they don't want to do that because it is a toll on their mechanical and their software limit. Well, not really a software, more of a mechanical and electrical. Network switches get overwhelmed, and you could simply make them slower so they don't get overwhelmed. But do you want to wait 10 minutes at an ATM line where everyone behind you swears at you? I wouldn't either. And obviously, there's a solution to this. To fix this, servers are grouped into clusters called pods. Each server gets a second location-based address called a pseudo-MAC address, which identifies which pod it's in. Let's say 4 of the 1,000 servers are in this pod, and there's 250 pods instead of 1,000 servers to send the address to. So this removes lots of work weights from the network switch. How it works. Simplified routing. Instead of knowing where the address of every server, a switch only needs to know how to route traffic to the correct pod. This dramatically reduces the amount of information the switch has to store. Like I said, instead of 1,000, there's 250, so it's not really a big deal anymore. The switch can handle it. Address summarization, a central control called Fabric Manager handles communication. When one server wants to contact another, the Fabric Manager intercepts the request and provides the destination server's pseudo MAC address. Between the servers, the administration, the Fabric Manager handles all of the communication so that there's no problem with the pods or the servers between them. Final delivery, once the data arrives at the contact pod, the local switch there translates the pseudo MAC address back to the server's real MAC address for the final delivery. The biggest advantage of this system is blah blah blah. It makes managing a huge network much simpler, and it doesn't need to change any software on the servers themselves. The reason it doesn't need to change any software is The network switch doesn't know the difference between a server or a pod. It just sends the information to the pod or to a server. It just sends the information to something. And that something doesn't need to be a server or a pod or a computer. It doesn't mean, it doesn't matter what it is. This is the reason you don't need to change the software, because the network switch doesn't care what it's sending information to. It is just sending the information it has. That is why it's a big plus, and it's really made in a simpler way than, let's say, a complex topology. This is why it's really it's really useful to have this topology. Data center terminology for beginners. So yes. Okay. Okay. I lost 3 recordings. One because my microphone wasn't working, so I had to change it with another one. And the other one, the pause button didn't work, so it removed all of the content. So I'm having a really good time. I've been re-recording this for 1.5 hours. This is why if I'm talking a bit fast, that's why. I don't wanna miss the coordination. Data center terminology for beginners. These are some of the words that you need to care about so you understand how the business works. I could read out all of these too, but for this, you just need to look at all of these words and you need to know what they mean. They are explained in a really simple manner, and you can just read them through this. Let's say, for example, mainframe systems are used centralized computing power connected to storage via director class switches. Director class switches use sorry, I was coughing a bit. Mainframe systems use centralized computing power connected to storage via director class switches. Director slash class switches are connected to the storage, and through the mainframe systems, they use the centralized computing power. All of these are words you would hear, so you don't get lost when you're talking with someone or you're applying for a job application. You don't get lost. You know what bandwidth means, you know what flexibility means, you know what security means, business continuity. All of these are words that you will hear when you're applying for a job like this, or when you're applying for anything else that is connected to data centers. You can read through here if you want to know any all of the words, and it's really good for you if you do. Why do young people want to work in mainframe fields? This was originally in the video saying why do millennials want to work in it, but I changed the topic a little bit. I commented myself on it. Why do young people want to work in mainframe fields? This is, sorry, this is just generally young people, Gen Z, Gen Alpha, millennials. Why do people want to work in this field in general? Well, there's a perception that new graduates like COBOL experience. The reality is that they are eager to learn. Companies should offer good training programs and mentorship to help developers succeed. A flat environment where everyone contributes to the problem solving is also beneficial. This is explaining how COBOL experience is required for people to work in the mainframe fields, but people don't have it because they are new graduates. And it's saying how people, or not this people, the companies need to understand how young people can only benefit, learn, improve themselves with them, because they need them to teach how, let's say, the mainframe fields work in the first place, or the COBOL experience that we are talking about right here, or in general, they need the mentorship from the older people who created this mainframe fields so that they can improve upon, they can take their place so the technology continues to advance and such. The mainframe offers significant opportunities for advancements, but technically and in roles like Scrum Master, many see the mainframe as being relevant as cloud technology with an insane amount of future potential yet to be discovered. This is extremely important for people saying the opportunities for advancement and the technology improving. This is extremely important because young people want to contribute to this new technology. They want to say, I am a part of this. Everyone obviously wants to do this, but as generation that were they were grown up with technology, they want to do this more because they take technology to a more personal area so that they can say, hey, I had a finger in this. I was doing this. I had my good share of work in this field and such. And here we have a small introduction to data centers. An introduction to data center concepts, components, and related design and operational factors such and such. What is a data center? A data center is defined as a department within an enterprise responsible for housing and maintaining backend IT systems and data stores. As it explains itself really simply, it is a place to store every information that exists and how to process all of those informations. Data center components, facility, physical location, physical space, physical access. Physical location. A data center can be a standalone facility or integrated within an existing building. Let's say you have a big building. Let's say the Google main building exists within an office, and or literally any company building that exists within an office, that you can have your own server to run your own company, because you need to have this big server so that your data is safe, your data is secure, your data is safe, you have your own privacy to do anything you want with your own data, and more than anything else, your clients that use your company for themselves, their security and their privacy matters more than anything else. Physical space, this includes the areas like data room for IT equipment, mechanical, electrical space, cooling, power infrastructure, a networks operation center for monitoring, staging area for unpacking and preparing new IT equipment. Physical access, security measures such as access control, surveillance, such and such, how people shouldn't be able to easily get into these places. IT infra, infrastructure, IT servers, the core computing power, communication equipment, devices such as switches, routers, ICP equipment for external connectivity, and patch panels for internal connections. The communication equipments are extremely important. Like I said, it needs to be fast, it needs to be reliable. Sorry, it needs to be fast, needs to be reliable, needs to be really protected at all times, because, hey, if I say you're not going to take your cash for another 30 minutes, people behind you would blame you and you would blame me. We want none of that. So this is why communication is extremely important. Storage equipment, storage area network, SAN, network attached storage, NAS. It explains in a short manner here, as we explained in the previous slides. Environmental sensors detect smoke, water, temperature, humidity, such and such. These are all extremely important for the continuity and the reliability of the data center itself. You don't want it to be too hot. You don't want it to be too cold. You don't want it to be too humid. You don't want it to be. You don't want there to be any smoke at all. You don't want any other chemicals and such. All of these interrupt the process that are happening in the servers, because servers are basically big computers, and you don't want to make them too hot, you don't want to make them too cool, and you don't want to especially get them any smokes in them, so the cooling systems wouldn't work properly and such, and chemicals obviously break the CPUs that exist within these servers. They're extremely all important. Electrical equipment, backup generator, ATS, automatic transfer switch, UPS, uninterruptible power supply, PDUs, power distribution units. Provides power during main power outages, with types including prime power, unlimited hours, and standby, limited hours. This is always saying that how long they can be reliable upon. Usually, they have prime power, unlimited hours, so that if there's a big power outage, they don't have problems. Automatic transfer switch automatically transfers electrical load to a backup power source if the primary city power fails. As it explains itself, it changes the switch from tick to tack. Let's say this switch is the main city power, and the other switch that you see my other down two middle fingers, this is the power supply, the backup generator. The city one fails, it opens and it immediately connects to the backup generator, so the load doesn't fail and the servers do not stop working. Uninterruptible power supply supplies immediate temporary power to data center in case of a power interruption. This this makes the power more stable. This makes the power, sorry, this makes the power more connected through the insides, and this works before the backup generator. Let's say it's a generator, it takes a while to open up. Before the generator opens up and gets the power for you, the UPS provides the power before the generator starts working. Power distribution units distribute electrical power to the IT equipment within the racks. The racks are the what servers are put inside of, by the way. As it says, it distributes power to the servers and such. Mechanical infrastructure, coolant containment, crack, computer room, air conditioner, chiller plants, raised floor. Coolant containment switches like cold or hot aisle. This provides a small placement. Is that in the middle? Let's say like this, and this is the middle, and this is the outside. My two middle fingers again. The outside between those parts and the wall. These are the hot aisles, and in between, this is where the servers are looking. This is the this is the cold aisle, where you could take the hot air that is happening in the cold room and you put it outside, so the cold and hot air already regulated inside between them. Computer room air conditioner supply cold air to the data center, as it says. Chiller plants, these are water plants that chill the hot air to again